Hello, Physics Nation. My name is Nate Larmond, and I've received a request to do an AP Physics problem. It's part of their AP Central's optional student review package, and it's kind of tricky. So, keep the requests coming. Makes me happy when you engage in the review. We still have 4 weeks, plenty of time to fill in whatever gaps are there. So, here's the problem. We have two cars, car X and car Y. This is actually OpenStax. Resource put out by Rice University, and it's weird. Their what do they call it? Test prep for AP courses matches the screenshot provided to me by this student, except the student said, and the language was confusing. The question here says, indicate which car, if either, completes one trip around the track in less time, and justify your answer quantitatively with appropriate equations. Then, part 2 says, justify your answer about which car, if either, completes one trip around the track in less time quantitatively with appropriate equations. So, OpenStax B1 says, and justify your answer qualitatively without using equations. And then part 2 says, justify your answer about which car, if either, completes one trip around the track in less time quantitatively. So strangely enough, this switch between qualitatively and quantitatively, I think, OpenStax got right. And I think this is a typo. But anyway, let's try this problem. Car X goes around the turns at VC. Oh, sorry, we're going clockwise. And then it says, for the straightaways, half of the distance it spends accelerating up to 2VC, and then the other half of the distance it spends decelerating, coming back down from 2VC down to VC. Car Y, on the other hand, gets up to 2VC in a quarter of the straightaway, maintains 2VC, double, that is the constant velocity it has in the turns, and then comes down from 2VC in the last quarter of the straightaway back down to VC. So, the qualitative answer is, well, car Y spends more distance at the high speed, 2VC, and so you would expect, qualitatively, car Y to win. So that is the answer to, where's the qualitative? This guy right here. Quantitatively, it's kind of tricky. So, it's a kinematics problem. We're looking for time. Time defines who gets around first. So I threw out some kinematics equations. No, we don't want these fancy guys. We don't want the definition of acceleration. We actually just want speed equals distance over time. That is, average velocity equals displacement over time. And that's the time to get around one turn if it's going at a constant velocity. So we just double that. That's the time to get around 2 of the turns. Straightaways are a little bit more tricky. We have to use the average velocity equation. So distance over time equals initial velocity plus final velocity divided by 2. Except for car X, the distance I'm going to do is the getting up to 2VC. So d over 2, that's half the straightaway. We're going to find this time. And what is the average velocity? Well, it goes from VC up to 2VC. All right, so we set the two average velocity equations equal to each other, do a little bit of algebraic magic, and we get the time to do half of the straightaway for car X is distance divided by VC, all divided by 3. That is 1/3 d divided by VC. It has to do that twice, obviously, because it gets up to speed and back down to speed. So if I did all of that right, the time for car X to get through, oh man, I'm not going to finish this in 20 seconds. Get through one lap. So did I double this? Yes, I did. So here are the two straightaways, and here are the two turns. And, common denominator, 6/3. 6/3 plus 4/3 is 10/3. See you in the next video.